Okay, how's it going, everybody? That's our next video in the online version of the course. Um, and I'm going to quickly just mention that I'm going to perhaps stop this and pause it a few more times than I have been. I got some feedback from students that they'd like me to zoom in when I'm writing sometimes so that they can see a little bit better. So there might be some few times where I stop and pause and then move it along. So I apologize if it's a little bit jerky, but trying to get so that more people can see a little bit better. And then as always, remember, you can pause and rewind. So if there's something I'm saying is not clear, or if I do some mathematics perhaps that you think is a little bit suspect, and I don't correct myself, you can double check and make sure that I'm right. Usually I think I've been checking, catching most of my errors, but certainly use the ability to pause and rewind as needed. Okay, so the last video that we had was all about understanding what the Pythagorean theorem is, why it works, and how we can explain it to somebody else. We saw a couple of different ways that the Pythagorean theorem could be explained. Today is going to be all about applying it, because it is really one of the more useful skills or strategies that we have for solving things, because it does such a great job at finding the lengths of lines. And we're trying to do that a lot so that we don't actually have to climb that tree and see how high up something is. We can do a calculation to figure it out. So it's actually quite applicable. So we're going to start with this though. Another skill or technique that we like to have is have our students try and figure out if these three lengths would create a right triangle, yes or no. And the Pythagorean theorem helps us with that. So I'm going to go ahead and here's the first set of problems here. I'm going to go ahead and zoom in so that we can see it a little bit better. And then I'll start doing some of the problems here. Okay, so if we're looking at this first one here, which is 6, 8, and 10, then the first thing I'm going to do is going to write down my Pythagorean theorem. And I'm going to write it over here like many of you like to write. A squared plus b squared equals c squared. And I actually, as we know, do not like that one. What I like instead is L1 squared plus L2 squared equals hypotenuse squared. And the reason I like that formula better is because it tells the kids what we're actually looking at. Now, the only thing they have to understand or know really, and this is true for A, B, and C, or L1, L2, and hypotenuse, is which of these dimensions is the legs, or the A, or the B, and which one is the hypotenuse, or the C. And so it's a little bit easier to explain to them or have them understand that the hypotenuse is always going to be the longest side. So I don't care how they're written, and I happen to write them in ascending order, but it doesn't matter. If you have three lengths that you find and it makes a right triangle, the hypotenuse will always be the longest side. So I can go ahead and plug those in now. And whenever I plug a number into an equation, I'm always going to use my parentheses. So I'm going to have 6 squared plus 8 squared, and each one of those, it doesn't matter if you flip-flop those, that doesn't matter. The only one that does matter is this one over here. It has to be the longest side, has to be the hypotenuse, and that's 10 squared. All right, so then I'm going to go ahead and multiply that out. So 6 squared is 36, and 8 squared is 64, and 10 squared is 100. And we see then that 36 plus 64 is equal to 100. So 100 equals 100. So what does that mean? Yes, it's a right triangle. Okay, that's what it means. So if the left side is equal to the right side, doesn't have to equal 100, left side has to equal the right side, then it's a right triangle. And when we do Pythagorean theorem, a lot of people, I gotta grab my calculator, Still, once again, I don't want you to use calculators. I don't think you need to use calculators. All we're trying to determine here is if the two sides will be equal or not really what they have to be equal to. So if you can't, figure out the exact number, can we tell if it's equal or not? Okay, so let me do the next one then. And so the next one is, once again, L1 squared plus L2 squared equals hypotenuse squared. Okay, and my L1 is 30 squared, and my L2 is 40 squared, and my hypotenuse is 50 squared. All right, so 30 squared, and you go, oh, I can't do that in my head. Sure we can. It's just going to be 3 times 3, right? And then you double the zeros, so that's 900. This one is going to be 4 times 4, which is 16, and then double the zeros. So 1600, and that's 5 times 5, which is 25, and then double the zeros. All right, so there we go. We got 900 plus 600 plus, or equals 900 plus 1600 equals 2500. 900 plus 1600 equals 2500. And sure enough, 2500 is equal to 2500. So yes again. Okay, so yes, that one is going to be a right triangle. All right, let's do one more here, and then we're going to stop and talk for a second. So first thing, as always, is L1 squared plus L2 squared equals hypotenuse squared. Now you may be asking yourself, do I really need to write the equation every single time? At this point in the semester, I hope you already know the answer to that. And for me, the answer is absolutely. If this is too much effort, then don't expect to be good in math, because that's not very much effort. To be good at math, we have to work hard and think and try. And if that's a lot of work, oh my gosh, I don't want to write down the equation every single time, then just don't expect to be very good at math. And if you don't require your students to be willing to put in this amount of effort, then you also shouldn't expect them to be really good at math. That's not very hard to do, and it's a way students learn and remember what the formulas are, so they don't have to try and remember them or memorize them. They just know what they are. So they write them down, they know what they are. Okay, so there we go. So then I have 6 squared here, and that is 8 squared equals 12 squared. All right, and then the next one is 36 plus 64 is equal to 144. And lastly, we see that 36 plus 64 is equal to 100. And that does not equal 144. So those are not equal to each other. So this is not a right triangle. Okay, so the left side does not equal the right side. So not all of them work, but the left side does not equal the right side. Therefore, it's not going to be a right triangle. Okay, so we'll pause here for a moment and take a look and see. So we had this one was 6, 8, and 10 did make a right triangle. Then we had 30, 40, and 50 also made a right triangle. And then we had 6, 8, and 12, and those did not make a right triangle. And now our next one that we have here is 3, 4, 5. And what I'm going to tell you on 3, 4, 5 is that 3, 4, 5 is a special kind of right triangle. In fact, it's called a special right triangle, 3, 4, 5. And what that means is that I don't really need to calculate this. If I have done it so many times and memorized that a 3, 4, 5 is a right triangle, then as soon as I see the dimensions, 3 feet by 4 feet, I know already that I need to have 5 feet in order to make a right triangle. Or if I have a triangle that looks like this, okay, like that, and there's my right angle, and I know that this is 5 feet and this is 4 feet, then I know the height of this triangle is going to be 3 feet. I can easily just figure that because I understand that a 3, 4, 5 is a right triangle. I would argue if you look back in your life of mathematics all the way through elementary school and high school, most of the triangles you've ever had to deal with where you're finding lengths of sides were 3, 4, 5s. We use them a lot. You say, I would have noticed a 3, 4, 5. We've already done it twice today. This one is a 3, 4, 5. This one is a 3, 4, 5. So this is the easier one to see. It's not really a 3, 4, 5. It's a 30, 40, 50. So that's fine. It means that what I'm doing here is I'm saying 3 times what plus, or squared, I guess. I'll just do it like this. 3 times what dash, 4 times what dash, and 5 times what dash. So there we go. Zoom out a little bit. Okay, so this number needs to be the same inside of each one. If I could find a number that goes in here that multiplies by each of those numbers that gives me this, then I know I'm dealing with a 3, 4, 5. So I know that it's 3 times 10, and this one is 4 times 10, and this one is 5 times 10. Since this is a multiple of a 3, 4, 5, I knew already that this was going to be a right triangle. This one up here is doubled. Instead of being 3, it's 6. Instead of being 4, it's 8. Instead of being 5, it's 10. So this is still a 3, 4, 5. And that's really helpful because if you start to notice 3, 4, 5s, then you can figure some things out quite quickly because you don't have to do all of this mathematics here. You can state that it's a version of a 3, 4, 5 right triangle, and then you can just calculate what the final answer would be. So what I mean by that is, like on this one, let's say you're trying to find the hypotenuse and you didn't know it was 50. Well, then you know, if you can see that it's a 30, a 40, then the next one would have to be a 50. Okay, so that's how we can use the Pythagorean theorem to determine if things are right triangles, and that one is what we call a 3, 4, 5. So if I look over here at this one, I look at that first one, is it a 3, 4, 5? So the very first thing I look at here is trying to determine, is this the 3, 4, 5? Well, there's a 5, right? And there's a 3 in it, but it's 13. So no, this one is not a 3, 4, 5. So in order to determine this one, if it's going to be a right triangle, I have to use the Pythagorean theorem. So that is L1 squared plus L2 squared, squared equals hypotenuse squared. And I just wrote it above it because it looks like I didn't give myself a whole lot of room here. I didn't want to run out. So, okay, so the next one then, it's going to be 5 squared plus 12 squared is equal to 13 squared. Okay, 5 squared plus 12 squared equals 13 squared. So 5 squared is 25, and 12 squared is 144, and 13 squared is 169. Okay, so if I look at that and I go, okay, 25 plus 144 is 169, and I see that is equal to 169. So that means yes, a right triangle. Okay, so we look at this and we see that a 5, 12, and 13 will create a right triangle. A height of 5, a base of 12, and a hypotenuse of 13. Or a base of 5 and a height of 12 and a hypotenuse of 13. So anytime you have 3 numbers that don't have any decimals or anything like that, then that means that these are special right triangles and they're always going to work out. And that means that any multiple of these will also work out. So I look at this one and I say, okay, is this connected to this one in any way? Well, I see I got a 5 and a 15. So that looks like I multiplied this one by 3 to get that one. Did I also multiply the 12 to get 6? Well, clearly no, I didn't. So that means that this one can't be a 5, 12, 13. It doesn't mean it's not a right triangle. It just means it's not the 5, 12, 13 right triangle. So the only way to figure that one out is if I go ahead and L1 squared plus L2 squared equals hypotenuse squared. And so my L1 is 6 squared. My L2 is 15 squared. And my hypotenuse is 20 squared. And 6 squared is 36. 15 squared is 225 equals, and then again I square that first number and then add 2 zeros, double the zeros. Well, I need to add those together. I can clearly tell that 36 plus 225 is not going to equal 400, so I know it's not a right triangle. Oops, not a triangle right. Okay, not a right triangle. And again, that's not because it's not a 5, 12, 13. It's because this didn't work out. They don't always have to be exactly the same. I mean, 5, 12, 13s. Okay, and one more here we'll take a look at. So now I'm coming down here to this one, and I'm going to check 3, 4, 5. Well, I don't have anything I can multiply 3 by that will get me to 10, or multiply 4 by that get me to 10, but I do have 5. 5 can multiply by 2. but I can't multiply 2 to get by 3 by 2 to get that one or that one, so that's clearly not that one. So it's not a 3, 4, 5. Okay, so for sure, not a 3, 4, 5. Then I'm gonna check my 5, 12, 13. So here's 5, 12, 13. If I double that, 5, I get to 10. If I double 12, I get to 24. If I double 13, I get to 26. So that means that this is, yes, a right triangle. And you don't even have to do any work. All I would ask you to do is to tell me that this is a 5, 12, 13 base right triangle. All right. So if you notice that each one of those can be multiplied by something to give you this new triangle, then you know it's a 5, 12, 13 or a 3, 4, 5, whatever. So these two, the 3, 4, 5 and the 5, 12, 13 are the ones that probably you have dealt with most often in your math career. We see them a lot. Everybody has 3, 4, 5s. And when you get to a little bit higher math, you start having to deal with 5, 12, 13s. And teachers like to use them because they won't have any decimals. I don't want you to think that all right triangles come out to perfect 5, 12, 13, or 3, 4, 5. You can have decimals for sure that still make a right triangle. In fact, most of them, I would argue, will be right triangles, will be decimals that are right triangles. And you're going to see some of that as certainly in the homework and as we move through. Okay. Next, what I'd like to do is just do a couple here and show you kind of what I want you to do as we get these problems. So now what we're going to do is solve for the missing side. So the base equals 8. The height we don't know, and the hypotenuse equals 15. Okay, so this is going to be a right triangle because I'm going to find the exact height that will make this a right triangle. When we were doing these a second ago, I was given 3 lengths and I was trying to figure out, does that make a right triangle? Here, I'm given 2 lengths and I need to calculate what the height needs to be in order to make this be a right triangle. So I know for sure it's going to be a right triangle. I have to figure out how high it needs to be. So what I'm going to do then is I'm always going to draw a quick picture because it's super helpful for me to see this and see what I have and see where the stuff is. So what I'm given here from my problem is a base of 8, the height I don't know, and the hypotenuse is 15. Okay, so there we go. So there's my right angle, that's my leg 1, leg 2, and that's my hypotenuse. Okay, so I'm gonna start with my formula, which is leg 1 squared plus leg 2 squared equals hypotenuse squared. All right, now my leg 1 is 8 squared, doesn't matter which one leg 1 is, and then leg 2 is x squared, and then the hypotenuse is 15 squared. All right, so now what I'm going to do is to multiply these out. So I get 64 plus x squared equals 225. And my last thing I'm going to do, or almost I guess the second last thing, so now I'm trying to solve for x. So that means I need to get x by itself. So I need to get everything away from x. So the first thing I'm gonna get rid of is the 64. I don't like having the 64 there. So I'm gonna subtract both sides by 64. And what I have left on the left-hand side is x squared. And what I have on the right-hand side is 161. All right? So I don't care what x squared equals. I care what 160, what multiplies to give me 161. I'm trying to find out how high is this. The height of this is not 161. The height of this is 161 square rooted, right? So what times itself gives me 161? So kind of I'm thinking about if this was a 12 here, 12 times 12 would be 144. That's pretty close. If it's a 13 here, 13 times 13 is 169. That's even closer. So I know it's somewhere between 12 and 13. I don't know exactly what it is, but somewhere between 12 and 13. So what I'm going to do to finish this problem off is I want to get rid of that square. Just like I got rid of the 64, I want to get rid of that square. The way I get rid of the square is to do that. So if you take the square root of x squared, what that does is simplifies out or cancels out the squares, and I'm left just with x. So all this square root does is get rid of that 2 right there. And then for us, for the homework tonight, you can leave it just like that. I don't care if you know what the square root of 161 is. It's not a perfect square, so it's going to be some decimal. I know it's going to be 12 point something, and if I had to guess, it'd be about 12.8. But if you plug this into your calculator, it's going to give you a super long decimal, so I'm not even going to worry about it. Just leave it as a square root of 161, and that's good enough. Okay? All right, let's do one more here, like that. Just so you get some practice seeing it done, and then we'll go to the fun stuff, which are the real world problems. So let's go with my length equals 9, my width equals 11, and what's the hypotenuse? Whoops. Okay. So there we go. So again, I like to draw a picture just so I can see what I'm given here. And it's good for my students when I do this because they can see what's given. So there's my right angle. So the length and the width are the legs, and the hypotenuse is always the one that's not touching the right angle. So that's my x. It doesn't matter which one I make, 9 or 11. It doesn't really matter. All right, so now I'm going to plug in or start with my equation. So L1 squared plus L2 squared equals hypotenuse squared. And zoom in a little bit, it's a little far away. Okay, so then I'm going to plug in my numbers. So my length, leg 1 is 9 squared. My leg 2 is 11 squared. And then my hypotenuse is x squared. Every time I plug a number in for a letter, I use parentheses. That's what I'm doing there, use parentheses. Then the next thing I'm going to do is just square everything out, simplify it. So I get 81 plus 121 equals x squared. Now this time when I do it, I don't need to move anything from side to side. I just need to combine like terms over here. I just need to consolidate those. So 81 plus 121 gives me 202. Let me write that a little bit lower. 202 is equal to x squared. But remember, I never care what x squared equals. I only care what x equals. So I don't know what x equals because I have that stupid square right there. I need to get rid of that square. And the way that I get rid of square is by square rooting that side. But if I square root this side to get rid of that square, I have to do it to this side as well. I can never do something to one side that I don't do to the other. So if I'm square rooting this side, then I need to square root the left-hand side. So the only thing the square root symbol does is get rid of that square. So on the right-hand side, I have x, and on the left-hand side, I have the square root of 202. And I don't care what it is. You can leave it just like that. That's perfectly all right. We will eventually get to a point and find a length there, but I'll tell you what I do know. It's going to be bigger than 11 because I remember that the hypotenuse has to be bigger than 11. So I know it's going to be bigger than 11. But other than that, I don't really care that much. And then we will figure out those at another time. Okay? Okay, so that's kind of how you manipulate the numbers. But what we really want to be able to do is solve problems that have Pythagorean theorem in them. All right? So let's go ahead and take this one out. And we're actually going to skip that top one because we just did a couple like that. So I'm going to not worry about this top one here. We just did a couple of examples, so it doesn't really matter. Okay, now let's take a look at this one. So here we want to find the height of an isosceles triangle. If we have an isosceles triangle, we want to find the height, excuse me. Okay, so here it is. I drew my picture already, and these are the dimensions that I have. The congruent sides are 13, and the base is 24. So what we remember about Pythagorean theorem is that we don't necessarily know if this is a right triangle or not. It didn't say it's a right isosceles triangle. It could be, but it doesn't have to be. So since I don't know if that is a right triangle, it didn't say anything about it, it just says it's isosceles, then I can't assume it is a right triangle. So now what? Well, I don't have a right triangle, so I can't use Pythagorean theorem, which is true. Except that we could create a right triangle. So if this is an isosceles, then that means that this point here could be dropped straight down like that, creating a height that is a right angle. And because this is an isosceles, I know then that this length will be the same length as this one. So this will be cut exactly in half. So if that's cut exactly in half, then what I end up with then is this. There's my height, and then I have $13 here, that's that part. But this part is not 24 because I just cut it in half. So I have some of it on the right-hand side, some of it on the left-hand side. If that's directly in half, then that means this is 12, like that. And now I know that I have a height here, which I don't know what that one is. So I can go ahead and put that in as x. And then I have the hypotenuse is 13 and the base is 12. So that means I can now I know that this is a right angle, right? Because I dropped it straight down to make sure it was a right angle. And so now I can go L1 squared plus L2 squared equals hypotenuse squared. And L1 is 12 squared. L2 we don't know, so that's x squared. And hypotenuse is 13 squared. So then I'm going to multiply that and I get 144 plus x squared equals 169, I believe. So then my next step is to get x by itself. So I got to get rid of that. Last time I could just combine them because there's two numbers on the same side. Here I have a number and a variable, so I can't just combine them. I have to subtract this one to get rid of it. So I'm going to subtract 144 from both sides. And what I have on the left-hand side then is x squared. Let's scoot this up. Is x squared. And the right-hand side, 169 minus 144 looks like it is 25. And then my last step is always to get rid of that square. So the way I get rid of squares is I square rooting. And I always made my students do the square root symbol over the x squared, never allowed them just to do one side. So they couldn't just do the 25. They always had to do the left side and the right side. And what I'm left with here is x, and on this side, the square root of 25 is 5. Now, a couple of you might have picked up on the fact that this is a 5, 12, 13. If you did notice that the 12 and 13 were in the right spot, meaning the 12 was a leg and the 13 was a hypotenuse, then you could have done, hey, I know that has to be a height of 5 because of 5, 12, 13. I mean by that, being in the correct position, these two couldn't be switched. If that's 12 and that's 13, then this is not going to be 5. It's just not the numbers, but it has to be the right numbers. Okay. So anyways, okay. So that's how we solve when we're not given necessarily everything we need. Meaning I didn't have a right triangle, but I could create my right triangle, and then I could go ahead and solve from there. All right, so now on to the fun stuff. Let me hit pause here. Okay, so here's the next part. We're going to do a couple of word problems here. We have 2 word problems to do, and then we'll be done for the night. A couple things I want to point out. There is no significance to this genius here and isolating there. That is just the strange sun exposure that my room happens to get, so don't think I'm trying to clue you in on something specific. Let me read it to you out loud, and then I'm going to zoom out so we can do some math here. Okay, so these 2 geniuses met in Fort Lauderdale last week during spring break. They were convinced they were convinced it would be a great quiet place to get some extra studying in for the MTE 281 class. After 10 days of completely isolating themselves from the rest of the spring breakers, ooh, how about that? Nice. They went back to their packed dorm rooms. One genius traveled west 330 miles. The other traveled north 440 miles. The question is, how far apart are their coronavirus infected dorms? All right. So this is a good time for me to mention when you start doing word problems, if you can bring something into your students that makes them pay attention a little bit more, like bring in students' names or things that they are interested in or things that are going on around the school, then you're going to get a lot better buy-in from your students. And so I always tried to write problems that had the other teachers' names in them or other things like that. In this case, it'd be obviously something's going on around in our lives right now that might be affecting us a little bit. Okay, the other thing I like to do is I like to put in lots of numbers in my problems as distractors, because I don't want them to necessarily just look for numbers and start plugging them in. So I try and make sure they're reading and understanding what they're doing by looking at for certain things. So the first thing that we care about here is, believe it or not, all of this up here is just fluff. It's just stuff that we actually have to filter through doing real world problems. The only thing that really matters starts right down here. So one genius traveled west 330 miles. The other traveled north 440 miles. How far apart are they? So these are the only two things that my students really need in order for them to do the problem. Those facts right there. Everything else up here is what life throws at us that we may or may not need to solve the problem. Okay, so I'm going to move this off to the side here, and then I'm going to do it. So the first thing I'm going to do is I'm going to draw a diagram. For me, it helps a lot if I have a diagram, if I can see what I'm actually doing. Okay, so here is Fort Lauderdale. Okay, there's Fort Lauderdale. And one genius went west. Okay, so if I'm at Fort Lauderdale here, then west has to be that direction, like that. And he or she, because I don't say if it's he or she went west 330 miles. Okay, the other genius went north. And that genius went north 440 miles. And the question is, how far apart are they? Well, this is how far apart they are. When they're done traveling, this one going 330, this one going 440, the question is how far apart are they? That's how far apart they will be. So now you might see when you draw it out what you have here, well, if one's going west, the other one's going north, that makes that a right angle. If that makes that a right angle, and I'm looking for this distance here, then that means that is the hypotenuse of this right angle. So then I'm looking for this distance, which is going to be my hypotenuse. Okay, with that drawn, now I can do my Pythagorean theorem. So now I have L1 squared plus L2 squared equals hypotenuse squared. And my L1 is 330 squared. And my L2 is 440 squared. And my hypotenuse is x squared. All right. So, okay. So right now, at this point, what I'm going to do then, I'm going to say, okay, 330 squared plus 440 squared is equal to hypotenuse squared. Now, I don't happen to know what 330 squared is, nor do I happen to know what 440 squared is. So how in the world can I figure out what x squared is? Well, I may not know what 330 squared is or 440 squared is, but I happen to notice that this looks a whole lot like 3, and this looks a whole lot like 4, and I'm hoping that this one over here, there might be a way to get that one, because then that would be a 5, if this is a 3, 4, 5 right triangle. So in order for this to be a 3, 4, 5 right triangle, I need to be able to multiply this by some number, and then multiply that same thing by that number. So what times 3 gives me 330? Well, how about 110? 3 times 110 equals 330. I'm really hoping that 4 times 110 is equal to 440. And I now know that 4 times 110 equals 440. Therefore, I know then that if I multiply this one by 110, then x will be equal to 550. So that's what x equals. All right, so there's a perfect example of looking for and using the 3, 4, 5. I think I'm gonna do the 3 and the 4 and the 5 in different colors so they stand out a little bit better. Sorry, I should have thought of that. 3, 4, 5. So as soon as I saw this was 33 basically, and this was 44, then I'm going, sweet, that's gonna be 55. But this isn't 33, it's 330, 440, so this is going to be 550. So I can do that without ever having to multiply these out. So if you get your students to look for 3, 4, 5s, they can cut themselves quite a bit of slack and be able to do things quite a bit more efficiently. Remember, at the beginning of the semester I mentioned, I'm not against shortcuts. I just want good shortcuts. Shortcuts that are going to be usable forever, not shortcuts that allow them not to do something else. Learn a skill, I mean. So here, because I was able to recognize that this is a 3, 4, 5, and then apply that idea, I can figure out that it's 550 without having to do the mathematics of it. So what I do know, though, is this side will be equal to that side if I were to multiply those out. Okay, so that's that one. So my two geniuses are then 550 miles apart. Okay, they went back to their dorm rooms, infected their whole dorm, and now they're at 550 apart. All right, this is the last one, so I'm going to pause it one more time. Okay, so here's the last question for the day here. And again, I'm going to read it to you, and that highlighted light there, there's nothing special about the word new. We'll go ahead and apologize. I don't know what these little marks are down here. I missed this paper, must have had something on it. I don't know where they came from, so I apologize for that. They don't mean anything as far as the problem goes. All right, I'm going to read it out loud to you again, and then we will take a look at it. All right, so this dude found a beehive in his backyard that's bugging him. He read online, so you know it must be true, that in order to safely knock down the hive, you must be approximately 2 feet away from the spot the hive will hit the ground. For every 3 feet, the hive is above the ground. He found a stick that is about 15 feet long. If he can hold the stick about 5 feet above the ground, he can reach the hive. He measured that at that point where the hive hits the ground, he is 8 feet away from where the hive will hit the ground. The question he is wondering is, am I going to get the crap stung out of me right now, or will I be safe? Figure out if he will be safe, then figure out what the shortest stick is he could have used to safely knock down the hive, because he, like the rest of us, is inherently lazy and is always trying to do the least amount of effort as possible. Okay, so there's a lot of stuff in there. But again, this is what we do with math. It's not about giving kids a list of numbers and having them manipulate the numbers. It's about looking at the problem, figuring out the problem, what it's telling me, what I need and what